and welcome to Geeks for Geeks. Today we would be discussing the problem named as number of distant islands. In this problem, we are given a 2D matrix of size n cross m and you need to find the number of island. So now the first question is, what is basically island referred here? So island can be referred as, suppose you can take all of the matrix as water bodies, okay? Like what is it is trying to depict it, okay? Like what this is trying to depict itself. Okay, so suppose this is a water body, you can just take it as a matrix, and let's say everyone is water at this point of time. So 0 depicts water. So at the next instance, if we just delete this part, if we just remove this part, and we have here as 1 would represent as land and 0 would represent as water. So now there is one more thing. So as this is a matrix, so if we just keep it here, just if we keep 1 here, then these two are of the same island. So a island, this one would be a part of some other one if it is not surrounded by water bodies in all the 4 directions. Simple. मतलब अगर एक पार्ट ऑफ लैंड है, अगर वो चारों तरफ से वाटर से घिरा हुआ नहीं है और वो किसी लैंड से जुड़ा हुआ है, तो वी कैन से कि वो आइलैंड का ये पार्ट है. दिस वी कैन से दैट. सो नाउ व्हाट वी कैन थिंक ऑफ इज that this is an island at this position and this is an island at this position. So there are 2 islands at this position. But the problem is that we need to find the distant ones. Now, what do you mean by distant? Distant does not mean the position here. It just means that it is the orientation of the land here. That here also see 1 1 1 1 and 1 1 1 1. If you observe, these two are same, only the position is different, so they would be constituted as same. So even if we have something like 1 1 1 and if we have 1 1 1, then these two would be considered as the same itself. Okay, that is why even if there are 2 islands, as they are same, the output is 1 itself. Let us move to the second part. So now we can see that here in this part, we have the first island at this position, the second island at this position. Okay. And if you observe, this is the same kind of island at this position. Okay. And this is the same kind of island at this position. So if you observe that these two are same, that is why this would contribute 1 to the number of unique islands, and these two are different. Okay, so we can say that there are total number of island is 3. Fair enough. So it is properly mentioned, not rotated or reflected. Okay, so this means that these two are different. That is why I drawn this two. Okay, so even if this is 1 1 1 and this is 1 1 1, so if this is rotated, you would see that these two are same, but it is told that we don't need to consider the rotation or reflection. Only the same thing would be considered, like the structure would be the same kind of structure. Okay, after rotating, what it does look like, we don't need to bother about that. Fair enough. So now the first problem is to find all the island. Okay, the first problem is to find all the island. Then we can think about finding the unique ones. So the first problem is find the islands. For how to find the islands? So if you observe, this is a heavenly water body and there are some islands in this position. Okay, so now we can say that if it is a graph kind of structure, the whole water body is a graph and these are connected components of a graph, then we just need to count the number of connected components in this water body, and that would be the number of islands, and that would be the islands. Do we have this kind of thing or not? Yes, we do have this. So now finding all the island is very easy. We just need to consider the whole thing as a graph, and then we can just do a DFS on the grid. Okay, and then we can find out the number of times we are doing a DFS. that would be the number of island. So if you're not familiar with this idea, how to find the number of connected components in a undirected graph in a grid, just consider reading this, because this is just a sub part of it. If this was the main thing in it, I would have explained it, but as this is the sub part of it, I am not explaining this. So let us just move forward to the next position. The next one is this one, that suppose we have a graph, okay, but here it is a grid and we just need to traverse the grid. So to keep everyone in the same page, I would just discuss with you what kind of ordering we would do, like how would we traverse the graph. So to traverse the graph, if you observe that from this position we want to move at this position, so the change in coordinate is x y plus 1, being first one the x and the next one as y. So if we move in this direction, that is y plus 1. If we move in this direction, that would be x minus 1. If we move in this direction, that would be y minus 1. If we move in this direction, that would be x plus 1. So if we observe that from a particular position, if we want to go up, down, left, right, then we can just do x plus 1, x minus 1, y plus 1, y minus 1. Everything else would remain the same. So what we can do is, if you observe, we can take help of a data structure known as array. Okay. So we can have something like 0, 0, 1, minus 1, and then we can have 1, minus 1, and here we would have 0, 0. And we would term this as x and this was y. So now if you observe that if the given value is x and y, and if we add the corresponding values, this value, like this would be x and y plus 1, if we consider this one. If we go to this part, this would be x and y minus 1. If we consider this part, this would be x plus 1 comma y. If we consider this part, this would be x minus 1 comma y. So you can see, by doing this kind of thing, by declaring an array of x and y of size 4, we can easily iterate over a particular point to all the 4 direction. Okay, you would have seen this. If you have not seen this, please learn about this. This is a very easy implementation that you can move forward with it, but it is a kind of smart implementation. It requires understanding, but the time taken to implement it and the ease of implementation it provides is worth the time given to understand this. Okay, so please consider learning about it. Okay, so now the next problem is, suppose we would just have all the island. Okay, so we have all the island, we know how to traverse the grid also, okay, by using the same a x and y. Now the problem boils down to the conclusion that we need to find the unique, okay, we need to find the unique ones. So if we want to find the unique ones, suppose we have a lot of things that contains duplicacy and we want to find unique ones. So if we want to find the unique ones, the first thing that should hit in our head is a hash map kind of thing. Okay. And in C++, we already have a data structure that is known as set. Even if you insert duplicate structure, it would only have the unique values. Fair enough. So we can directly use the set and we can just store all the islands in it. And then we can say that, yes, this would just give me the number of islands. But the problem is that suppose the island at this position is like this and the island at this position is like this. So let's say this is 0, 0, this is 1, 0, okay, and this is 1, 1, and the same kind of structure is somewhere here also, like we can say that this is 8, 8, 8, 7, and then we can think of as 7, 7. Fair enough. So we can have this kind of structure. So now suppose this is a structure that we have. Now both are same itself. So how can we just try to have both of them? We need to make both of them equal. Let us try to think. So if you just observe these two things, okay, if you just observe 8, 8, 7, 7, and here 8, 8, then you can see that the first coordinate is, and the second coordinate has a difference of, this is x plus 1. The same kind of thing, that is, this is x plus 1. Just see the coordinates, how it is changing. It is x plus 1 and y plus 1. And if we have something like x is equals to 0 and y is equals to 0, if we consider this, then this would be x plus 1 comma y, and this would be x plus 1 y plus 1. In the same way, if we consider x is equals to 7 and y is equals to 7, then this one would be x plus 1 comma y, and this would be x plus 1 comma y plus 1. Okay, so we have this kind of thing and we are following this kind of pattern. So if somehow we are able to equalize the x and y, then the problem is solved because the difference is equal. So we need to concentrate on the difference, not on the starting values. Okay, so if the difference is same and the starting values is different, then what we can think of is, if we just subtract the starting value, then we would have a similar kind of structure. Like, let us subtract the value 0 0 from everyone. So if we subtract the value of 0 0 from everyone, this would be 1 1, this would be 1 1. In the same manner, if we subtract 7 7, the starting value from everyone, we would have 7 7 minus, so 7 7 minus 7 7 is equals to 0 0. 8 7 minus 7 7 is equals to 1 0. So we would have 1 0. And here we would have 7 8 8 minus 7 7, it would be 1 1. And here it would be 1 0. Sorry about that. This one would be 1 0. Fair enough? So if you just observe that these two are equal. So now what we can do is, we can have a set of coordinates, okay? And if we just subtract the originating value, then we would have a similar kind of structure. Like if you store this in a vector, if you store this in a vector, then you would observe that this is 0 0, this is 1 0, and this is 1 1, and this is 0 0, this is 1 0, and this is 1 1. This is how you can equalize, and these two would be treated as same in the set itself. Now let us just summarize everything. So now the first thing we saw is that we need to find the number of islands, and they are situated, they were connected, they are considered as one island. So we can see that we can find the island by doing a simple DFS kind of structure. But the problem is that we need to find the unique ones. So first we understand that we need to traverse it. How we traverse it? See, we can see the pattern that if we go up, this is x minus 1. If we go this side, this is xy minus 1. If we go this side, this is x plus 1. And if we go this side, this is y plus 1. So in the same manner, what we can do is we can simply traverse it. Okay. So now moving forward to the next one, that is, if we see the same pattern, then we can saw that if these two coordinates, they are very different, but the difference in them is the same. So what we did was, the points were different, but the difference is same. So we just subtracted the originating value. Here in the first coordinates, we subtracted the value 0 0. In the next coordinate, we subtracted the value 7 7. At the end, we have the same kind of thing. So now to store the coordinates, we won't have a 2D kind of structure. Rather, we would just store it in the vector and we would insert them in a set. Okay. So let's repeat everything in Hindi so that this problem is crystal clear before we implement. So हम लोगों ने क्या देखा कि एक आइलैंड है, अब वो दो जुड़ा हुआ को आइलैंड बोलेंगे, मतलब जो लैंड जुड़ा हुआ रहेगा उसको आइलैंड बोलते हैं, सिंपल. ओके. एंड सारे आइलैंड को निकालने का तरीका यही है कि हम लोग पूरे आइलैंड को एक ग्राफ मान लेंगे और जहां तक हम लोग डीएफएस कर पाएंगे उस पार्ट को हम लोग एक आइलैंड बोल देंगे, और जितनी बार डीएफएस चलेगी हम लोग बोलेंगे उतने नंबर ऑफ आइलैंड्स है यहाँ. ओके. अब थोड़ा आगे बढ़ते हैं. We can see that from a particular coordinate we can go up, down, left and right, and so that we have derived an array and we would just add the corresponding values to move left and right. Okay. So now if we move forward, we saw that हमें अब तो सारे मिल गए हैं, अब हमें यूनिक फाइंड करना है. यूनिक फाइंड करने के लिए मोस्टली हम लोग क्या कर सकते हैं कि सबको सॉर्ट कर लो, फिर जो कंसेक्यूटिव होगा उसको डिलीट करते जाओ. ओके, लाइक 1 3 3 5. तो हम लोग क्या कर सकते हैं, 1 एक उठाए, 3 एक उठाए, 5 एक उठाए. और उससे भी सिंपल तरीका क्या, हम डायरेक्टली एक सेट में इंसर्ट कर सकते हैं और सेट से यूनिक वैल्यूज को ही स्टोर करेगा. ओके, फेयर इनफ. हम लोग आगे बढ़ते हैं. सो हम लोगों ने देखा कि अब यूनिक वैल्यूज हमें पता कैसे चलेगा कि दोनों सेम है. दो कोऑर्डिनेट्स बनाए सिमिलर काइंड ऑफ स्ट्रक्चर के, बट हमें लगा कि 0 0 1 0 1 1 काफी डिफरेंट है, 7 7 8 7 और 8 8 के. तो हम लोगों ने क्या किया, हम लोगों ने देखा कि जो डिफरेंस है वो काफी इक्वल है। मेन डिफरेंस पॉइंट्स है, बट पॉइंट्स के बीच में जो डिफरेंस है वो काफी सिमिलर है। तो हम लोगों ने क्या किया, जो ओरिजिनेटिंग वैल्यू जहां से हम लोग स्टार्ट कर रहे हैं उसको माइनस कर दे रहे हैं। अगर हम लोग माइनस कर दिया तो हम लोग देख रहे हैं कि हमें सेम काइंड ऑफ थिंग आ जा रहा है। हम लोग पॉइंट्स कैसे स्टोर करेंगे, पॉइंट्स हम लोग वेक्टर में स्टोर कर देंगे, सिंपली सारे को सेट में इंसर्ट कर देंगे। जितने वेक्टर यूनिक होंगे उनका वैल्यू, उनका साइज निकाल के हम लोग रिटर्न करें। Now let us move to the coding part and we would have a much better understanding. Okay, so for simplicity, I already have the dx and dy array, and here I would be doing the dfs, and here I would be having this. So I would first find the number of rows, which is nothing but g dot size itself, and the number of column, which is nothing but g dot size itself. Okay, and G is the graph that is given, grid that is given. Now we would have a set of what? Vector of pair of int comma int itself. Okay, and we would name it as pos so that we would store all the position in it. And next we would just traverse everything. For int I is equals to 0, I is less than n, I is less than r, and I plus plus. Then what we would have is we would have something like for int j is equals to 0, j is less than c, and j plus plus. This is to see that we are just visiting everyone or not. Okay, so we would say that if g is g dash I dash j is not equal to 1, okay, if it is 0, then we would continue because we don't have any problem with 0. तो जीरो तो आइलैंड है नहीं, तो उसे कंसिडर करके कोई फायदा है। कंटिन्यू। ओके, नाउ वी वुड जस्ट हैव अ वेक्टर ऑफ पेयर ऑफ int comma int. Here we would have the vector from the DFS, like DFS would be visiting each of the coordinate and we would be pushing each one of them in the vector itself, and then at the end we would just insert each one of them in the pos. Now what we would do is we would do a DFS of the graph. We would pass G the graph, okay, and then we would pass the coordinates, okay, x naught and y naught, that is the initial x and y, and then we would again have the originating position, that is x and y itself, okay, I and j, and then we would simply have the vector to store the vector, and then we would have pos dot insert whatever the coordinates we are having, we would just insert them to the vector. And then let's go to this part. Okay, now what we would do is we have passed the vector by reference, vector of pair by reference, so that we can just have all the values saved itself. Okay, so now here also we would first find the size. Okay, so so we're copying this. This is the small mistake. Yeah, so I will just copy this. Okay, copied. We have the value of rows and columns in R and C. Okay, so now the first is that we are going out of bounds or not. What do we mean by this? That suppose from this position, it might be a scenario that we are trying to go here and this is not valid. So we need to check that the position we are trying to visit is it is within the boundary or not. So we can say that if I is less than 0, it is not within the boundary, or I is greater than equal to R, it is not within the boundary. If J is greater than less than 0, not within the boundary. J is greater than equal to the column, not within the boundary. Or G of I dash J is less than equal to 0. Okay, that means we are whatever we are visiting, we would just multiply it with -1. Okay, like whatever it is already visited, we would just make it -1 and we would return from that position. This is not a valid thing. So now the next thing what we are doing is if g of I and j is 1, we would be multiplying g of I and j multiplied by is equals to -1. Okay, so if it is 0, so 0 into -1 would remain 0. If you observe, anything multiplied by 0 would be 0. Okay, if you observe, 1 with -1 is 1. So if you just see that we are visiting all the ones and we are making it -1. Okay, but the 0 ones are intact. So this is a substitute which is used instead of using the visited array. So we are not using a visited array. Rather, what we can do is we can use simply multiply it with -1 so that the 0 remains intact, and all the ones we are visiting, it would be converted to -1. This is the main agenda. So now we would have b dot pushback this current position, because after this point this is valid. So first the points are I and j, but we need to remove the originating position, that is x naught and y naught. Okay, and we would have it at this position, and then we would have int k is equals to 0, k is less than 4, and then k plus plus, and we would just add the corresponding values like defs of g and then x naught and y naught. Okay, the current position, okay, the initial position and the current position, which is dx of k. We're just adding the corresponding values to move left, right, up, down. Okay, I plus dx of k and j plus dy of k itself, and the v that we are trying to find. Is this clear? So after this point of time, we are done. So now we would just return pause dot cycle. Now just try to compile and run and see how many errors are we making. So let me just try to see. Okay, so we are having an issue at this position. Okay, so now what we need to do is we need to have the vector at this position. So vector of pair of int, int, and then we would have and v itself, and then we will just close it. And after that, we will just open it. So I hope this is clear. So let us just compile and run again. Okay, we are making a correct output for the sample test case. Let us try to submit and see. And yes, we got an AC. Let's talk about the time complexity of this problem. As we are visiting each node exactly once, that is why the time complexity of this problem is big O of n cross m. But we are storing each of the node in a set, that is why it is log n into m also. Okay, now the next thing is, what is the space complexity? The space complexity is constant if you don't consider the given g, else it is big O of n into m itself. If you were here till this point of the solution, consider liking the video and commenting on the video for better reach of this video. Thank you and have a nice day.